Welcome to today's lesson. We're going to study the Nairobi School Examination, Mathematics Paper 1. The section 1 of this paper has already been uploaded in Shifting Grades online school. So you can follow up with our programs to see the workings in this section. So this lesson, we're going to handle the section 2 of this exam, which begins from number 17. I'd like to encourage you to subscribe to our platform and also to share so that you may invite a friend to Shifting Grades. This is your home for mathematics and physics. This is where your grade is going to be shifted to a better grade in mathematics. So cooperate throughout the session. Number 17. The question says in part A, we complete the following table for the function y equals to 2x plus x minus 6. Then the table is running from -4 all the way to +4. That is the values of x. And so we're supposed to calculate the corresponding values of y for every value of x. So ours now is to substitute in the original equation because y is given by, for example, the first value of x is -4. So we write 2, then we open brackets for -4, and we square, then plus a -4, then we add 6. So when you compute that from your calculator, you are going to get, exactly 22. Then for -3, you substitute in the place of x, -3, and the value of y shall be 9. Then you substitute -2 in this equation for you to get the value of y, which turns out to be exactly 0. You substitute -1. Those who are slow, we are just writing y equals to 2. If it is x -1 now, then you square, then plus a -1, then we subtract 6. So remember to subtract 6 that way. This is also -6. That's also -6 that way. And you do the same for every other value. So at this point, at -1, we'll be getting -5. And when x is 0, the value of y shall be -6. Then at x equals to 1, y will be -3. At x equals to 2, you substitute and get y as 4. At x equals to 3, you substitute and get y as 15. And finally, when x is 4, the value of y shall be exactly 30. So with the table that way, you are already having 2 marks. The next thing, be plotting now. Now that we have the coordinates of x, y, for this particular function, part B is demanding on the grid provided, we draw the graph of y equals to 2x squared plus x minus 6 for the values of x ranging from -4 all the way to the +4. The axes have already been labeled very well with the y-axis. For 1 unit, we're having 5 units. That's 1 centimeter, 5 units. But for the x-axis, 1 centimeter, 1 unit. So we start with the first coordinate, -4, 22. -4, 22. So -4 is here. Let me change my color there so that I may plot very well, yeah? -4, 22. So -4, 22. That is the coordinate. -3, +9. -3, +9. +9 is just below 10. That way. Then we go to the next value, which is -2, 0. So -0 means this point. -2, 0. Then at -1, we are having -5. -1, -5. -1, -5, this point. Then 0, -6. Then +1, -3. +1, -3 is here. Then we are having a +2, 4. Then +3, 15. +3, 15. 15 is here. Then finally, +4, 30. So +4, 30 is the coordinate at this point. +4, 30. So we are having the plotted coordinates. And now we need to connect them using a very smooth curve. A very smooth curve to come up with the graph of the quadratic function shown there. So now I join using a very smooth curve, smooth and continuous. The curve is supposed to be very smooth. Smooth and continuous. I'm trying to be as perfect as possible. Yeah, this way. And now we are turning. Now, something that you're supposed to know is that, we are having let me show you the coordinates. 0, -6, not 0, -5. Look at this point. Coordinates there should be 0, -6, so it should be here. And that becomes our turning point because it's the lowest point possible in this curve. So that is the point at which we are going to turn. Yeah, that is the turning point for the curve. That way. So we are having the curve already drawn. Very smooth. This is the curve. Y equals to 2x² plus x minus 6, that way. So we have the graph that way. Part C, solve for x in the equation x² plus 3x plus 2 equals to 0. So now we should know that when we are given equations to solve using a graph, we usually subtract the plotted function. Let me show you. The plotted function is y equals to 2x² plus x minus 6. Then we subtract the function to solve such that we have 0 here equals to x² plus 3x plus 2, that way. And when you look at this, you discover that x² is having different coefficients in the two equations. And so we should make it the same by multiplying the first equation by 1 and the second one by 2, so that the coefficients of x² are equalized, because we want to come up with a linear equation. So the first equation now remains y equals to 2x² plus x minus 6. Then here 0 equals to 2x² plus 6x plus 4. Yeah, plus 4 that way. Then now we can subtract. Subtracting these means we shall have a negative 6 minus 4, giving us negative 10. Then we are also having 6, okay, x minus 6x. That will give us negative 5x. X minus 6x, negative 5x. Then 2x minus 2x, that one cancels to 0. 4 minus y equals to y. So this is the straight line now that we are supposed to draw. So we can get to a small table of values for this straight line. Like when x equals to 0, the value of y will be negative 10. And when the value of y is 0, when the value of y is 0, we substitute there so that you may get the value of x. 0 equals to negative 5x minus 10. So 10 equals to negative 5x. So that x becomes negative 2. Yeah, so we have a table, a small table of values. So we need to plot. We need to plot 0, negative 10. This is the coordinate, and also negative 2, 0. Yeah, negative 2, 0 is already plotted. So now we do this straight line. We do the straight line so that we may get the line that will be used to represent a graph. So I'm supposed to draw this one now. Let me do a very straight line. Or I can add one more constant. Let me check here. What if we go for the value of x being, let's say, even x becoming a negative 3. So you will have the third coordinate as negative 5 into negative 3. Then we subtract 10. This is going to be 5. So negative 3, 5. Negative 3, 5. Negative 3, 5 shall be here. Yeah, negative 3, 5 shall be there. So now we can connect the 3 dots. The 3 dots should be connected. So let me draw. That is the straight line. So we are supposed to identify the points along the curve. The points along the curve where the line is intersecting with the curve. And that is at two values of x, negative 2 and negative 1. The points on the curve where the line is intersecting the curve, points of x at the intersection of the line and the curve. This is going to be negative 2, negative 1. So the roots of this shall be negative 2, x, negative 1. These are the two values of x that we wanted. So we first reduce the quadratic equation into a linear equation, after which we plot the linear equation. Then where the linear graph is cutting the function, now we get the values of x at those points that way. Finally, find the values of x when y equals to negative 5. When y equals to negative 5, we're going again to draw a curve. Y equals to negative 5. Let me draw the line for you people. Y equals to negative 5 is this line, a horizontal line. Yeah, that's the line y equals to -5. Y equals to -5. So now, again, where is this line interacting with the original curve? And I'm getting -1 and 0.4. So -1, the first point here. The other point is here, 0.4. So -1 and x equals to 0.4 positive that way. So that's how we deal with the graphical question. It has been my encouragement to all students, whenever you find a graphical question, kindly try it out. In most of the cases, a graphical question will not have any trick. It will just be very open for you to work it out. But now we are number 18, which is now not graphical. So let's look at number 18. A model of a cylinder is made in such a way that it is similar to the shape of the actual tank to be constructed. The curved surface area of the model is 550 square centimeters, and that of the proposed tank is 22 meters squared. Part A. Given that the height of the model is 40 centimeters, calculate the height of the actual tank. So this is similarities and enlargements. What you're supposed to know is that we have already been provided with areas. So the ratio of areas will give us area scale factor. So area of the model is 550. Area of the actual is 22. So we first convert the units so that we may get the area scale factor. So area scale factor shall be 22. We multiply by 10,000 to get square centimeters or so, divided by 550. So area scale factor shall be 22 or 220,000. We divide this by 550. So I'm getting 400. That is the area scale factor, which means we can get the linear scale factor by simply taking the square root of area scale factor. So the root of 400 shall be equal to 20. So if we have the linear scale factor, now we can relate lengths, because lengths are measurements in one dimension, and they are related using the linear scale factor. So if we are having height of the model and we are to calculate height of the actual, then we shall multiply it by, we multiply 40 by 20 to give us 800. The examiner has advised we do it in meters. Those are very special instructions. Calculate the height of the actual tank in meters. So we have now to convert 800 centimeters to meters by dividing it by 100. So we have height of the actual tank as 8 meters. That is it. It's very good at this point to remember that. In case we had been given height of the actual tank, for us to get height of the model, then we would have divided by linear scale factor. But now that the height that we need, the one which is bigger, then we increase it by multiplying. Look at part B. Calculate the volume of the model, given that the diameter of the actual tank is 7 meters. It's also good for you to remember that what has been provided here is diameter, which is a linear measurement. This question can have two approaches, and I want us to try the two of them. I will start by doing the first method, whereby we can get volume of the actual tank. Volume being cylinder, right? Yeah, being cylinder, the volume can be given by pi r squared multiplied by height. Therefore, pi r, the radius is 3.5, squared times the height of 8 for the actual now. So we will talk about 22/7 multiplied by 3.5 squared multiplied by 8, giving us 308. That way. So we have volume of the actual tank. And with this, we can talk about volume scale factor. Now that we are having linear scale factor as 20, we need to raise it to power 3 so that we get volume scale factor. So volume scale factor is linear scale factor cubed, 8,000. This is the volume scale factor. And which volume are we having? Volume of the bigger. Volume of the bigger. Now that we have volume of the bigger, for us to get volume of the smaller, for us to get volume of the smaller, then we need to talk about division. 308 out of 8,000. So volume of the smaller shall be 308 out of 8,000, giving us 0.0385 meters cubed. So this one is the volume of the smaller tank. We've gotten volume of the actual. Then using volume scale factor, we are able to get volume of the smaller. Again, we can apply linear scale factor first and say that the linear scale factor is 20 and we are given diameter of the actual tank. So what will be diameter of the smaller? So diameter of the smaller shall be 7 divided by 20, because you have to divide it by, 7 divided by 20. This gives us 0.35 meters. Remember, this one is diameter, so we can make it radius by dividing by 2. Radius of the smaller tank, meters. What about height of the smaller tank? Height of the smaller tank has already been provided as 40 centimeters, which is 0.4 meters instead of 40 centimeters. So volume can be gotten directly now. Pi r squared times height. Pi r squared, h 22/7 multiplied by 0.175 squared multiplied by 0.4. This gives us exactly 0.0385 meters cubed. So this is the volume. So we can use linear scale factor. This one is the method 2. This one is method 2. This is method 1. So in method 2, we have started by the linear scale factor so that we may get radius of the model. Then with that, we can get volume using the formula. In the first method, we got volume of the actual tank. Then using volume scale factor, now we compute volume of the smaller. So any of those two approaches is taking us to the same answer. Now find the volume scale factor and hence calculate the volume of the actual tank in cubic meters. All right, now this one, it's like the examiner didn't know that we can calculate that one in advance even. So volume scale factor equals to 20 power 3, giving us 8,000. Then with, we have cubed linear scale factor. So with volume scale factor, that one is already done. Hence, calculate actual volume or volume of actual tank. So volume of the smaller is here. So we need to say volume of the bigger is when we take volume of the model and we multiply by volume scale factor. So 0.0385, we multiply by 8,000. This will give us 308 cubic meters. That way. So we have already done, though we did it before in our first approach. Yeah, we had done it already. So that is it. That is it. Now, number 19 is a question on what we call scale drawings. This is bearings and distances. We're going to interpret the question together until we get what exactly the examiner needs from us. So we are told in number 19 that 4 towns A, B, C, and D are such that town B is 84 kilometers from town A on a bearing of 0.63 degrees. Town B is 144 kilometers on a bearing of north 60 degrees towards the west from town C. So it's good for you to know that this is called true bearing. This one is called the compass bearing. Town D is directly to the west. Directly to the west of town C and on a bearing of 161 degrees from A. Again, very serious instruction there. Look at part 1. We are told, using a scale of 1 centimeter represent 15 kilometers, draw a diagram to show the relative positions of the towns. These are 4 towns whose relative positions now are going to be shown. So the first thing that we are doing here is to start interpreting the first statement such that B 84 from A on a bearing of 0.63. So we begin by A. When you hear from A, that will be our reference point. So we start by drawing point A. By drawing point A, you just raise a compass at A. This is our point A. So while we are at A, we are supposed to measure 63 degrees. Remember, being a true bearing, we're supposed to measure it from the north and in the clockwise direction. That is the meaning of true bearing. Strictly measured from the north and always in the clockwise direction. It can be any angle that way. Then once we have measured the angle of 63 degrees, now we get back to the distance. 1 centimeter is supposed to represent 15 kilometers. So we take 84 and we divide it by 15. So 84 over 15, this is 5.6. 5.6 centimeters. So it's 5.6 centimeters. That will represent 5.6. Yeah, 5.6 centimeters. Then once you arrive at point B, then you measure again the angle of 63 so that you may raise a compass on the lower side now, so that you may raise a very perfect compass at point B. We're supposed to measure again the acute angle you measured at A, which is 63. So I'm going to measure 63 very accurately. 63 that way. Then I do my compass. I raise my compass now. That way. So I've measured a 63 here, so that the compasses are very parallel to one another, very vertical. So this is my point B. We continue interpreting now. We are done with the first statement. Town B. Town B is 144 kilometers. 144 kilometers on a bearing of north, 60 degrees towards west from town C. Very interesting. So we are given town C as the reference point, and yet we are not having the C. So we are given directions to B. So with that, you should know that you are supposed to go to, you draw separately now, C and B. C and B. So this is C. And how do you access B from C? You access B from C by measuring 144 kilometers on a bearing of 60 from north towards the west. So you go to the, when you hear north, 60 towards west, it means you stand at north and you measure 60 in the direction of west. So you measure 60 in the direction of west. So like that. 60 in the direction of west, which means once you arrive, once you measure the distance now and you arrive at B, then you are supposed to measure 60 on the lower side for you to raise a very perfect compass that way. This means now, with this interpretation now, we can trace the position of C with reference to B and say, C, look at this interpretation now. Point C, according to my sketch now, C is from south, 60 degrees towards the east, 144 kilometers from B that way. If B is north 60 degrees towards west, then C from B shall be from south 60 degrees towards the east. So now, again, we confirm the distance to be measured there. 144 out of 15. We'll measure 9.6. So this one is represented by 9.6 centimeters according to the scale. So we measure 60 this time round now. We're going to measure 60 from the south. Remember, 60 can also be constructed without even being measured. So we measure 60 and we draw a line there. That way, very smooth line. Then now to my ruler, just a minute here. I have to ensure that some things are very accurate here. Yeah, so I'm supposed to measure now 9.6 centimeters. 9.6 centimeters on my ruler. 9.6 is going to be at this point. That is 9.6, and this will be my position C. Now, at this point, I'm supposed to raise again another compass. Because I measured 60 on the lower side, now I should measure 60 on the upper side. So we draw a compass, very sharp one. Wait, that is C. We drew 60 at this point. So I had to measure another 60 at this point for my compasses to be very sharp, parallel to one another that way. So we have position of C. Finally, where is D? Where is D? Town D is directly to the west of C. Now, when it means directly to the west, it means we are moving to the left hand side. That is the meaning of west. Directly to the west. Directly to the west. So we are supposed to, we just produce directly to the west. So anywhere along this line, that is directly to the west. The meaning of directly to the west is anywhere along this line. More instructions about D is that directly to the west of C, that one is done. And also on a bearing of 161 from A. 161 from A. 161 from A. So we measure an angle of 161 from A. We measure an angle of 161 from A. So 161, 60, 61, 161 from A, and we produce that line. That is the angle of 161. Remember, it should be from the north. So if the whole of this, the whole of that angle is giving us 161. That means with 161, we can get the smaller angle that remains there, 19. So we have a small angle of 19 here. And that means at point D, for us to raise a compass, now we're supposed to measure 19 on the other side. Because we're having 19 on the inner side, now I'm supposed to measure 19 on the upper side. Here, 19. Somewhere here. Wait, supposed to be more accurate. Erasing my angle of 19. So you see now the relative positions of these towns have already been shown. So we are already having our compasses very properly drawn. This is now what I expect from my followers. Should be in a position to come up with compasses like that, to come up with relative positions like that. Now, let's get to part B. From the diagram, find part 1. We are doing a few measurements here. The distance from town A to town C. So from town A to town C, we're supposed to use a very straight line, or you just use your ruler, and your compass. Remember first, A and C can be joined using a very straight line. So that's the length we need. So you first measure it in centimeters, and you're getting 13.5. Get 13.5 centimeters. So you're supposed to multiply this by the scale of 15 for you to know the equivalence in kilometers, 202.5. Kilometers. So we must work with actual distance now. After you've gotten the scale distance, you multiply it by scale to get the actual distance. Look at part 2, the true bearing. The true bearing of town A from C. True bearing means we are measuring the angle strictly from the north and in the clockwise direction. So the angle that we need in our case now, and remember, it is from C. A from C, not C from A. So A from C, it means we stand at C and we measure the whole of this angle. The whole of that angle. From the north in the clockwise direction. So this angle is going to be, this angle is exactly going to be, let me estimate it for you. In a very quick way. To estimate it for you. Around 280. Yeah, around 280. But let me show you a quicker way of doing that. A quicker way of doing that. Yeah, let's say 280. 280. 280 that way. We usually allow an accuracy of 1 degree, so it can be plus or minus. That's just an estimation. Just an estimation. So we can measure it and we estimate that way. Yeah, that way. It's well estimated. The compass bearing of town D from B. So D from B. You know, a student must be understanding what all these types of bearings are. True bearing and compass bearing should be well differentiated. It should be well differentiated. I've connected B and D. So we need from B. So when we talk about compass bearing, it should either be from the south or from the north. It is towards either the south or towards the west. From south or north, towards either west or east. But when you look at this one now, from the south of town B, for us to access D, we should move to the west. So that is the acute angle we need. It must also be an acute angle from either south or north towards either east or west. So in this case, we are moving to the west. So we just measure that acute angle. We measure the acute angle. This angle is exactly 42 degrees. So if it's 42 degrees, then we are moving from the south 42 degrees towards the west. That way, 42 towards the west. Now, the distance of town D from C. D from C, that means we measure the length DC. Just measure the length DC, which is 12.5 centimeters. 12.5 centimeters. Now, for us to get the actual distance, we multiply by scale, and this is going to give us actual distance 187.5 kilometers. Now, this will vary with an accuracy of, together with this one, the actual can be 13.5 plus or minus 0.1 centimeters. So that now, depending on what you are converting using the scale now, the accurate answer in the actual distance now will also vary. So a student having 13.4 and also 13.6 will be considered accurate. Here, where the accurate answer is this, we add or minus 0.1. So a student with 12.4 centimeters, then they convert it well, they will get right. A student with 12.6 centimeters and they convert it well, they will also get their mark right. So that is it. That is it. So that is the question on scale drawings, specifically distances and bearings. Very simple question to interpret, and I hope that you guys have understood it. Number 20. So we would like also to continue requesting for your support from wherever you are. If you need to support our programs, kindly use the till number displayed on the board to support Shifting Grades online program. So 49 777 42. Any amount will go a long way. Any amount is highly appreciated. So please utilize the till number here, and we shall keep streaming lessons for you. Otherwise, thank you so much for the great support. We appreciate. Number 20, part A. The distance from city A to city B is 720 kilometers. A Nissan Matatu left city A at 8 a.m. and traveled towards city B at an average speed of 90 kilometers per hour. Half an hour later, that is at 8:30, because half an hour means 30 minutes. So at 8:30 a.m., a car left city A towards city B with a 30 minutes stop along the way before it caught up with the Nissan Matatu. If the car caught up with the Nissan Matatu at 12:00 hours, calculate part 1, the distance covered by the Nissan Matatu when it was caught up by the car. You know, the Nissan Matatu is the one that began the journey at exactly 8. And now it's being caught up by this Nissan. It's being caught up by this car at 12 noon. So 12 noon from 8 a.m. These have been 4 hours, 00 minutes of traveling at a speed of 90. So 90, the speed multiplied by 4 hours. This is giving us 360 kilometers. So these kilometers have been covered by the Nissan Matatu by the time it's being caught up. By the time it's being caught by the car. It has been moving for 4 hours without stoppages, and it's moving at a speed of 90 kilometers per hour. So we are already there, 360. Now the next question is, the speed traveled by the car. All right. You know, for them to catch up, because they are all starting from Nissan Matatu left city A. They are all moving from city A. That means for the car to catch up, it has also moved an equal distance. Therefore, we want to see what is the time the car has been moving to cover the same distance. So the car started at 8:30 and it's catching up with the Nissan Matatu at 12 noon. That means because it again stopped for 30 minutes, then it means we will take the time difference from 12 and 8:30 when it began. This is going to be giving 30 minutes. Then 11 minus 8, giving us 3 hours, 30 minutes. But we shall subtract again the 30 minutes stoppages because from 8:30 to 12 noon, there are 3 hours, 30 minutes. But within these 3 hours, 30 minutes, there is a break when the car was not moving. So that means we have exactly 3 hours. 3 hours of motion. Therefore, the distance of 360 has been moved within 3 hours by the car. And this gives us 120 kilometers per hour. This one is now the speed of the car. That becomes the speed of the car. Very simple. Speed of the car. 120 kilometers per hour. A very good question. Actually, this one is not the questions that a student should get stuck. You just have to understand this information, you interpret it wisely, and you'll be good to go. Now, at number part 3, Roman 3 of this question, the time the car arrived at city B. The time the car arrived at city B. So the total distance is 720. Now, assuming that it will not stop again, the remaining distance is 720 minus the 360 covered before catching up. So we have 360 kilometers more remaining to be covered. This 360 is going to be covered with a speed of 120. So it will take exactly 3 hours. And assuming that it will not stop anywhere else now, assuming there will be no stoppages again, it's now 12:00 hours, and we are adding 3:00 hours. That means it will be arriving at 15:00 hours. This is the time of the day the car is going to arrive. So we are done with the first 7 marks of this question. So we now go to part B of this. We start interpreting part B. Oh, remember, this time can also be expressed as 3:00 p.m. That is the 12-hour clock system. It will still be correct. Part B, Priska took a train from Mombasa to Nairobi. During the journey, another train was traveling in the opposite direction on a parallel track at a speed of 25 kilometers per hour. If the train she boarded was traveling at a speed of 15 kilometers per hour and it took 10.8 seconds to completely pass the other train, calculate the length in meters of the train Priska was traveling in if it was twice as long as the train moving in the opposite direction. Here we have to work with some unknowns, and we're also supposed to interpret distances very keenly. We're supposed to interpret distances very keenly. So what we're supposed to know is that we are told that calculate the length in meters of the train Priska was traveling in if it was twice as long as the train in the opposite direction. So train in opposite direction, train in opposite direction is X meters long. Then we have the other train now, which is the Priska's train. Now this one is twice as long as the other one, meters long. So calculate the length in meters of the train Priska was traveling in if it was twice as long as the train in the opposite direction. So that one now is a good interpretation first. Then now look at this now. Let me draw it. We have one train and another train. So we have 2 trains here. We have 2 trains here. there is Prisca's train, which is 2x, and it's going in this direction. Then another train, which is going in the opposite direction, x meters long. So for this train to completely overtake the other one, it is supposed to move until it covers the distance x. Then it moves. For it to completely overtake, it has to move its own distance, its own length. Therefore, total length for these two trains now, total length for these two trains is going to be total length, which will be moved for the train to completely pass through one another, 3x. So the Prisca's train will move through a relative distance now of 3x meters. Then, because they are both overtaking one another, not overtaking, sorry, they are passing one another. They're just meeting and completely passing one another. Then we shall talk about a relative speed, which is supposed to be a sum because they are moving in opposite direction. Summation of 15 and 15 and 25. So 15 and 25, giving us 40 kilometers per hour. 40 kilometers per hour. But now we can multiply the kilometers by 1,000. And we also multiply the hours by 3600 to make them meters per second. Therefore, 40 multiplied by 1,000, then 1 hour multiplied by 3600. This will give us 11 and 1 out of 9 meters per second. Yeah, 11 and 1 over 9 meters per second. This one is now the combined speed, which is going to be used to completely cover the relative distance. Now, what you're supposed to know is that there is relative distance, the distance taken to cover the relative speed. And that distance is what we are going to express right now. So we shall say that the distance of 3x is given by relative speed times relative time. So a relative speed of 1, 1, and 1 over 9 multiplied by a relative time, the time taken to completely pass 10.8. 10.8 that way. So 3x equals to, when we multiply this by 10.8, I'm getting 120. Then for me to remain with x, I should talk about 120 over 3, giving us 40 meters. This is now the train which is moving in the opposite direction, which means for us to get Prisca's train, then we shall talk about twice long, 80 meters. 80 meters. That is the length of Prisca's train. So that's how we were supposed to interpret such a question. So thank you so much for following up. We are looking now at number 21, a very serious question on transformations. And I hope that you guys shall follow keenly and make sure that you get the best from this question. The vertices of a quadrilateral A, 1, 2, B, 4, 4, C, 3, 2, and D, 5, 1. Draw quadrilateral ABCD on the grid provided. So let's begin by drawing 1, 2. Let me first label the Cartesian plane. So I'm having 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, -6. -7 that way. Then we are having a -1, -2, -3, -4, -5, -6 that way. So point A is 1, 2. So coordinate 1, 2 should be there. That's our A. Then B is 4, 4. So 4, 4. B is there. Then we have coordinate C. Coordinate C is 3, 2. So 3, 2. That's coordinate C. Then D, the last coordinate D is 5, 1. So when we talk about 5, 1, we should be talking about this point D. So for us to get this particular quadrilateral, we're supposed to join all these coordinates. So we join the coordinates using straight lines, and we join them according to the name. According to the name. So we can't move from A to C, even if C is closer to A. Let students master this, please. People make mistakes of just joining coordinates blindly without knowing that there is a name that should be followed. A, B, C, D. Therefore, from A, we go to B, according to the name. From A, we join it to B. Then from B, we bring B to C. Then from C, we join to D. From C, we talk about D. Then from D, now we get back to A, so that we may complete now the figure. So this is how the figure is supposed to be. That's how it's supposed to be. A, B, C, D. That is it. The first mark is already pocketed. We proceed to part B of this question, which tells us, this one is telling us that A prime, B prime, C prime, D prime is the image of A, B, C, D, and a reflection in the line X equals to 0. Draw A prime, B prime, C prime, D prime, and state its coordinates. So you're supposed to understand that in a reflection, what you should be very careful with is what you call the mirror line. So the mirror line here is X equals to 0. X equals to 0 is also the line Y-axis. X equals to 0 is the line Y-axis. So we are reflecting along the Y-axis. If it's coordinate A, we take it to the opposite side, an equal distance. So A prime shall come there. If it's B, we join it perpendicular to the mirror line and we move an equal distance to the other side. So B shall come to this side after moving an equal distance on the mirror line on the opposite direction. Then C shall move to a point like this. This where C shall be. Then we also talk about D. We shall come to a point like this on the opposite direction. But it's prime. Sorry, not double prime, but just prime. Yeah. C is also prime. C is prime. So now we can join. Again, using the order A to B first. A to B. Then from B to C. Then from C, we connect to D. Then from D, we get back to A now. Connected to A. Very straight lines. That way. So we are now having the figure and its first image after a reflection along the line Y-axis, which is also called line X equals to 0. So with this, Now we can state coordinates. A prime is equal to -1, 2. B prime equals to -4, 4. Then we have C prime whose coordinates. C prime whose coordinates is -3, 2. Then finally D prime shall be -5, 1. -5, 1. That way. So we are having the image together with the coordinates. Now part C of the same. And guys, remember to comment, remember to like, remember to share, remember to invite a friend. Remember to be a subscribed member of Shifting Grades Online School. The best for your education. Part C. Now A double prime, B double prime, C double prime, D double prime is the image of A prime, B prime, C prime, D prime after 90 degrees turn, positive 90 degrees turn, about 0, 0. That's the origin. Draw A double prime, B double prime, C double prime, D double prime, and state its coordinates. So we're supposed now to rotate. When you're told 90 turn, it means a rotation. A turn is a rotation. Let learners know that a turn is a rotation. Positive 90 means in the anti-clockwise direction. A positive angle is usually measured in the anti-clockwise direction. Anti-clockwise direction. Therefore, if we join A, then we should move 90 in the anti-clockwise direction. So let me join A to the origin because that is the center. So we join A to the center, A to the center, that way. Then at the center, now we measure 90 and in the anti-clockwise direction, not clockwise, anti-clockwise direction. Then we are supposed to move an equal distance. You should remember that. So we measure 90 and to move in that direction an equal distance. So we move this way for an equal distance, which means we shall be at a point here. And this point, you see this is a 90 degrees angle in the anti-clockwise direction. Therefore, that becomes our A double prime. So this is A double prime that way. Then we do the same for B, for C, and for D. So let me bring a coordinate like B to the same center. So I bring it to the origin. I bring it to the origin. Then now along that line, I measure 90 degrees, specifically anti-clockwise direction. 90 in the anti-clockwise direction. Then I'm supposed now to measure an equal distance. I move along that line, an equal distance. Equal distance. So an equal distance will find me at a point like this. Yeah. At a point like that. And I continue. This will be my B double prime. B double prime. That way. Then I continue. I do the same for C. So I bring C to the center with a very straight line. C to the center. Then now I measure an equal distance. C to the center. Then I measure 90 once again. in the anti-clockwise direction. And along that line for D, I shall move an equal distance. So when I move an equal distance along this line, then for C, I'll be at this point. Yeah, equal distance. That is where I will be. So this becomes my C double prime. Then finally, I'm talking about D now, the final coordinate, which is D. So I rotate D by joining it to the center of rotation. I join it to the center of rotation that way. Then I measure. Then I measure 90. Remember, the 90 should be measured in anti-clockwise direction. Then I move for an equal distance. I move for an equal distance along that line. So along this line now, I'm supposed to move an equal distance, and I'll find myself at a point here, which is D double prime. D double prime that way. So you see now, I am having all the coordinates of the second image, so I can join them again in order from A to B first. From A to B, then from B to C, from B to C, then from C, I go to D, and from D, I connect back to A. That way. So I'm having now the rotated figure. The rotated figure has been drawn. After this, now we can talk about the coordinates. Negative for A, I'm having -2, -1. For A double, -2, -1. Then for B double prime, let me check it. B double prime, this is -4, -4. Then for C double, I'm having -2, -3. And finally, for D double prime, D double prime is -1, -5. -1 and -5 that way. So I'm having the coordinates. So there is a final part here, which is a part D. Part D in this question. Draw A triple prime, B triple prime, C triple prime, D triple prime, the image of A double prime, B double prime, C double prime, D double prime under an enlargement, center 1, -3, scale factor -1. So we first identify the center of the enlargement, then the scale factor. When the scale factor is -1, it means it will be now on the other side. So the image and the object will be on opposite sides of the center. So we move to the opposite side, and it will be, we just move once, just an equal distance. Therefore, I'm supposed to identify the center first, 1, -3. So center 1, -3 is here. The coordinate 1, -3 is here. That's our center of enlargement. Then after that now, I'll talk about joining every coordinate to that center. Then we move an equal distance to the other side. Equal distance means if it was -2, we would move twice the same distance. But now we're moving only once the same distance. So we join A to that particular center. We join A to that particular center. Then after joining, we just proceed an equal distance to the other side. And A is identified. So an equal distance will give us our A triple prime that way. We proceed again. We do the same for B. So we join B to the center. We join B to center 1, -3. Then after joining, let me increase the accuracy a little bit. I'm supposed to be very accurate. So B is joined to the center. B to the center. Then I move an equal distance to the other side. Now, when I move an equal distance for B to the other side, I'll find myself at a point here. So this B, 1, 2, that way, triple prime. I do the same for C and for D. So I join C and I move to the opposite side, an equal distance. So C is going to be here, C triple prime, that way. And finally, we talk about D. So D is joined to the center of enlargement. Then we move an equal distance to the other side. That way. So when I move an equal distance, I'll be having D at this point. So this will be D triple. That way. With the coordinates identified that way, now I can join them for me to get the image. So from A to B, remember the order is very key. Sorry. Let me use a different color, please, at that point. So I can use a color that we've not been using it, like this one. Yeah, this one at this point, that way. Then we join. Then from B first to C. From B first to C. Then from C to D. Then from D back to A, so that I get the full figure. See now? So we have the full image after the enlargement. The full image after the enlargement. Have we been taught to state the coordinates? Not really. We just enlarge that way. So we have enlarged that way through a center. Scale factor -1. That way. So we are already done with the 10 marks for question number 21. For question number 21. So now we can check something in number 22. Wow, this is a question on equations of straight lines together with gradients. Equations and gradients. This is from 2 work. A very good question and a very good concept, which students are supposed to know that it rarely misses in a national exam. This one, together with the transformations we've just done here, they rarely miss in a national exam. Therefore, students are advised to take some of these concepts very serious. So give every concept the seriousness it deserves. And that is why we are choosing the best papers for you guys, so that you may get exposed to what is expected in the national examinations. Remember, for you to support our programs, you just need to use the till number 497772. Any amount will go a long way. So please feel free to support us, and we shall keep growing together. Now, number 22, let's start the question. A straight line L1 has its x-intercept and y-intercepts as -3 and 6, respectively. Look at part A of the question. Write down the equation of L1 in the form AX plus BY plus C equals to 0, where A, B, and C are integers, not constants, integers. Very simple question. So now to interpret this, remember, you're supposed to interpret the intercepts as coordinates. When we talk about intercepts, this is what we mean. Let me just interpret intercepts for people, for them to know what we are saying. Assume this is our Cartesian plane. So we're supposed to know that x-intercept and y-intercept respectively. So the x is at -3, then +6. -3 is a point here, and 6 is a point here. Therefore, the line passes such that it cuts the x-axis at -3 and the y at 6. So if the curve passes that way, the line, not the curve, sorry, if the line behaves this way, then it means these particular y and x intercepts can be written as coordinates. So the first coordinate for the x-intercept is -3, 0. And for the y-intercept, it's 0, 6, that way. So with two coordinates, we can get what we call gradient for this particular L1. So gradient 1 will be given by change in y, 6 minus 0, over change in x, 0 minus -3. So this will be 6 out of 3, giving us 2. So the gradient is 2. If the gradient is 2, we can express it for us to get now the equation. So gradient 2 is given by, we assume another coordinate xy. So that we say change in y, y minus 6, y minus 6, out of change in x, x minus 0. So now we can cross multiply and have 2 multiplying x minus 1 equals to y minus 6. That one will multiply 1. So 2x minus 2 equals to y minus 6. At this point now, we can arrange the terms so that we take the format which has been dictated there. So we begin with the term that as x, and then the term that as y, so it will be subtracted here. Then the constant, so we have -2, minus 6 becomes positive. So -2 plus 6 becomes 4. So that on this side, we have a 0 that way. So that's how we're supposed to get the equation that way. Let's check the part B of number 22. Part B of number 22 says this. Another line, L2, which is parallel to L1, passes through coordinate P, which is 1, 2k, and also through coordinate Q, which is -2k, 6. Find the value of k. Now, the concept that we should use here is a parallel to L1. For parallel lines, gradients are usually the same. Two parallel lines share the same gradient. Therefore, the gradient 2 will be equal to gradient 1, and this is 2. Therefore, how do we get gradient now? 2 equals to, according to the provided coordinates, change in y. So 6 minus 2k divided by change in x, so -2k minus 1. That way, then now we can find k by cross multiplication. 2 into -2k minus 1, 6 minus 2k. Then this will be -4k minus 2, 6 minus 2k. That way. So we can now group terms, right? Grouping terms means -2 minus 6 becomes negative 8. That's where I've brought the constants. Then now the variable k will be taken to the other side, whereby I'm having negative 2k. Then I add 4k, because 4 should become positive on the right. That will be 2k. So that the value of k simplifies to negative 4 after dividing through by 2. So k equals to negative 4. Value of k equals to negative 4. That way. See, now with that value of k, we can get the coordinates of p and the coordinates of p and q. That's why they are being used in part C now. Find the equation of the perpendicular bisector. Very serious concept here. To the line joining P and Q. So the coordinate of P shall be, let me get back to P, 1, then 2k. 2 by k becomes negative 8. Hope we are together there. Then Q becomes negative 2k. You know, negative 2k means negative 2, then k, which is a negative 4. So this becomes positive 8. Negative 2 into negative 4. That becomes 8, then 6. That way. So we are having the coordinates now. We are having the coordinates of P and Q. Now look at the question. Just look at the question. Find the equation of the perpendicular bisector. Perpendicular lines have a certain relationship, and that is their gradients multiply to give us negative 1. Therefore, this perpendicular bisector will be having a gradient. You know PQ is having a gradient of 2 since it is parallel to the first line. That means the line 3 here, the line 3 in this case, will have a gradient equal to negative 1 over 2. So I'm taking the reciprocal with the opposite sign. So that when negative half is multiplied by 2, they will simplify to a negative 1. So we have the gradient of this perpendicular bisector. But for us to get the equation, we need to know a point where this line passes. So the line passes at the midpoint because it is a perpendicular bisector to PQ. So it passes exactly at the middle of PQ. So if it passes at the mid of PQ, how do we get the coordinates at that particular point? So now we engage vector 1, the midpoint of a vector, such that for us to get where they are meeting, we can call it a point R, the midpoint R. We need the first x plus the other x, that is 1 and 8. Then we take the average. And on the other case, we take the first y, the second y, and we divide by 2. So the coordinates of R, the midpoint of PQ, shall be 9 over 2, 4.5. Then negative 8 plus 6, that's negative 2 over 2, negative 1. So we are having a coordinate where the line, where this bisector is passing now, and we have the gradient. Then we need another point, xy, for us to get the equation. So negative 1 out of 2 equals to change in y minus negative 1, divide by change in x minus 4.5. So cross multiplication will give us 2 into y plus 1 equals to negative 1 into x minus 4.5. This will be 2y plus 2 equals to negative x, then positive 4.5. That way. We can have any format for this equation because the examiner has not dictated any format. Actually, we can begin with x being positive. Then we are having 2y here. Then 2, we subtract 4.5 and get negative 2.5. negative 2.5 equals to 0. So the equation can even take that format. So we are already done. The equation can be in any format as long as the examiner has not specified. Yeah, that is it. So I hope you guys are getting something in this platform. But remember, there is the general format of the equation of a straight line, whereby after this stage, we can have, at this stage, we can have 2y remaining here. Then we have negative x and 2.5 after 2 is subtracted. Yeah, after 2 is subtracted from, when 2 is subtracted from 4.5. So to remain with y, this negative half x plus, this is already 2.5, so we divide by 2 to get 1.25. Sorry, to get 1.25. That way. So the equation can still be in terms of y equals to mx plus c, which is the general equation of any straight line. That way. Yes, let's get to part D of this. Part D of this. In part D, we are taught to calculate the angle which line 1 makes with the x-axis. Line 1, where is line 1? Let's get back to line 1. That is the line we sketched. It is making a certain angle with the x-axis. It's making a certain angle with the x-axis. There is an angle here. So now we can even, because the two axes are meeting at right angles, so we can use the 3 units here and the 6 units here. They will help us to get this particular angle. They will help us to get that particular angle. But even without sketching, we are supposed to know that tangent is usually equal to gradient. Tan 2. You know, the tangent here is 2. Tangent of this line is 2. And the gradient of the same line is also 2. This is what we mean. Geometrically, we know that tan of the acute angle at that point will be opposite length out of the adjacent length. And again, gradient will be change on the y-axis. You know, the y-axis is also the opposite. Divide by change in the x. Therefore, at the end of the day, you will discover that on the y-axis, which is our opposite, there are 6 units. On the x-axis, which is our adjacent, there are 3 units. Therefore, the value of gradient equals to the value of the tangent. That's what you're supposed to be applying. So we say that tan of the angle equals to the gradient of the line. So tan of this unknown angle equals to the gradient of 2, meaning that the angle itself shall be given by the tan inverse of 2. So when I write shift tan 2, I'm getting 63.43. That way, 63.43. So that is the part D already worked out. Very simple and very easy to understand. All right. We are almost concluding. Remember, guys, to share. Remember to subscribe. Remember to invite a friend to Shifting Grades Online School. Consider the area enclosed by the curve y equals to x squared plus 2x, the x-axis, and the lines x equals to -2 and x equals to 3. Part A, estimate this area using Roman 1, the mid-ordinate rule with 5 strips. So let's check how this area shall behave first. how the area shall behave. So I'm going to use some tables here. Allow me begin by just doing a table of values for this particular curve between -2 and +3. So I'm having x, then the values of y. -2, -1, 0, 1, 2, 3. That way. For me to get the first value of y, I need to take 2 squared. Okay, -2 squared plus 2 into -2. So this particular value is supposed to become 0. The value of y is 0. So the value of y in the second part, when x is -1, I just open brackets and write -1 squared. Then I add 2 into -1, and this gives us exactly -1. Then at 0, we also get 0, because when we substitute 0 in this function, y becomes 0. Then x equals to 1, I'll get the value of y as 3. Then when we are talking about x being 2, I'll get 2 squared, that is 4, plus 2 into 2, which is again 4. So that gives us 8. Then when we have x as 3, it will be 3 squared, that's 9, plus 2 into 3, which is 6, and we get 15. Very simple. I'm doing this first table so that we may begin by doing a sketch of the curve. A sketch of the curve, you discover that we have 0, -1, then we go to the positives. 0, -1, then we go to the positives. So the curve basically will behave this way. Basically, this is how the curve shall behave. So we are having at -2, we have a 0. Then at -1, we also have a -1. Then at 0, we are having 0. Then at 1, we are having 3. Then at 2, we are having 8. Then at 3, we are having 15. At 3, we are having 15 that way. So now I can sketch the curve comfortably. I just need a sketch of this particular curve. Yes, now you see how the curve is behaving. Part of the area is on the, this is from -2, -1, 1, 2, 3, that way. So now the area is this way. We have, these are what we call strips now, because we are taught to estimate using 5 strips. So we have 1, 2, 3, 4, 5. So the area can be divided into 5 strips that way. So with 5 strips and the mid-ordinate rule, we are supposed to know that the mid-ordinate rule does not use the values of y, which we are already having. It uses the middle values. At these strips, what is the middle height at each strip? So for us to get the middle height for the first strip, we go back to the function again. We go back to the function. So now I've stopped. I'm now back to the curve again, so that we may know for the first strip, we need the value of the height when we are using the value of x as the middle, and that will be -1.5. Then for the next strip, the middle value of x shall be -0.5. And when we go to the other side of the x-axis, we'll talk about 0.5, then 1.5, then 2.5. So we need the values of heights at the middle values of x. So the middle heights now is what we need, the middle heights. So at negative 1.5, the middle height shall be 0.75, but negative 0.75. Then at negative 0.5, we substitute again in the function, and we get the value of y as negative 0.75. Then at 0.5, we substitute again in the function, and we will get 1.25. Then at 1.5, we substitute, and we get 5.25. And finally, at 2.5, we'll get 11.25. 11.25 that way, 11.25. So these are the middle heights now. These are the middle heights, and that is what we use for what we call area by mid-ordinate rule. So area by mid-ordinate rule is given by h into the first y plus the second y plus the third y, all the way up to the last y added. So h is the uniform width of the strips. So the uniform width of the strips, or from one mid-ordinate to the other, we are having only one unit. From 2, negative 2 to 1, negative 1 to 0, that way. The intervals are just 1 unit. Then now the heights, as we have gotten them, we'll be adding. Something else that you should know is that for us to get area, we just need now the sizes of these heights, regardless of their sign. We just need the size. So negative 0.75 means that is the height on the lower side of the x-axis. So we just want the size, and we will pick 0.75. So we ignore the negatives and pick the absolute values. So what we need is the size. What we need is just the size of these heights. So because we need the sizes, then we can ignore the signs and just get the specific height, the specific value y. This will give us exactly 19.25 square units. .25 square units that way. So we have used what we call the mid-ordinate rule. Now, in part 2, we are taught to use the trapezium rule with 5 strips. Now, area estimated by the trapezium rule is always given by half h into the first height plus the last one, then 2 multiplied by all the other heights. All the other heights. So we continue adding them to the height just before the last one. That way. So this is the formula according to the trapezium rule. So we'll be taking half multiplied by the uniform width of the strips is 1 unit. Then the first height. Now for the trapezium rule, we use the heights. We use all the heights. So the first height is 0. The last one is 15. Plus 2 multiplied by all the other heights in between there. So we'll be having, instead of -1, we use the size of the height, which is just 1. So we will not apply a negative. So we use 1038. 1 0, 3, 8. That way. So this is a 0.5 into 15 plus 1 plus 3 plus 8. That gives us 12 times 2. That gives us 24. Yeah, that gives us 24. Then now, final answer shall be, when we add 15 to 24, then we multiply by half. We multiply this by half. We are getting 19.5. Spare units once again. So these are the two estimations using the trapezium rule, whereby we use the original values of heights. But for the mid-ordinate rule, we need the heights at the middle. The heights at the middle. That way. Let's look at part B of this. Calculate the area, actually the actual area enclosed by the region, the same region. Hence, work out the percentage error using the trapezium rule to estimate the area. So let's get actual area. Actual area is area done using integration. Now, the reason why I sketched this curve is in case there was a question on integration, we may know how to play around it. Therefore, you can see the area is not on one area. The area is not on the same region. The area has been split into one area is below the x-axis, another area is above the x-axis. So we shall integrate twice. We start from -2 to 0, then from 0 to 3. So we will be integrating this function. Area will be, we integrate partially from -2 to 0. The function is x squared plus 2x. With respect to x. Then we add, again, an integral from 0 now to 3 of the same function with respect to x. So this will be the total area. So this is what we shall be integrating now. Be very careful in this integration. Very careful in the integration. So when we integrate the first part here, x power 3, the power increases to power 3. So x becomes power 3, and the new power divides here. So we have a third x squared, now x power 3, plus we have a 2x. So x becomes power 2, and the new power divides. When the new power divides, 2 will cancel. So it will be x squared, then plus the arbitrary constant of integration. Then we are having 0 from -2, plus, you know, it's the same function. So it will be x power 3 out of 3 plus x squared, not over anything, plus the constant of integration. This is from 0 to 3, that way. So in the first part, we begin by substituting the bigger, which is 0. So when you substitute 0, it will be 0 power 3 out of 3 plus 0 squared plus a constant minus, when we substitute -2, -2 power 3 over 3 plus -2 squared plus c. That way, that will be the first integration. So in this one, we will be getting c minus 1 1/3. So you see the constant shall cancel, and we get -1 1/3. This one is the final integration. We should know that the first area The negative is just showing us that the area is on the lower side of the x-axis. So the absolute value of this will become the area, 1 1/3 square units. Then we will talk about the second area now. In the second area, we will be substituting first +3. So we will have in this second now, we have to substitute in this one, sorry. In this second one, we substitute 3 first. So 3/3/3 plus 3 squared plus c, then minus when we substitute 0. And when we substitute 0, we shall just get c that way. So this is going to become exactly 18. So the constant disappears. We have 18 square units. So the area before 0 is 1 1/3, and this one is 18. The one above here, this one is 18. So we can get total area by adding now. Total area shall be 1 1/3 plus 18, giving us 19 1/3 square units. This one is the actual area, 19 1/3 square units. So area by integration in this part is 19 1/3. Now you can see the estimated areas, 19.5 and 19.25, but the actual area, 19 1/3 square units. So the other thing is to find the percentage error when using the trapezium rule. So we need to, for us to get percentage error, we need error over actual times 100%. So the error shall be, when you use trapezium rule, we are getting 19.5. So we take the difference between 19.5 and the actual area, 19 1/3, that is the error, out of the actual area, 19 1/3. Then we multiply everything by 100 to express it as a percentage. So when you use a calculator very well, you discover that the percentage is 25/9%. And 25/29% becomes 0.8621. Percentage 0.8621% for significant figures. So that is the error. So we get error first by substituting actual and estimated. Any can be bigger than the other. So what we need is just the difference that will give us the error. Any can be greater than the other, because if we were to find error when the mid-ordinate rule is used, we would start by the actual area, 19 1/3 minus 19.25, because the actual one will be greater in that case. But now the estimated one using trapezium rule is the one greater. Number 24 and the last question in this. A rectangle floor whose width is 5 meters shorter than the length as a perimeter of 75. Part A. Taking x squared plus 15x to represent the width, write an expression to represent the length. We are told that the width is 5 shorter, which means the length is 5 longer. So the length shall be x squared plus 15x plus 5. That way, meters. Yeah, that is becoming our length. The units are not a must, but that is the expression now in meters. Then we write another expression representing the perimeter. You know, generally, perimeter of a rectangle is 2 length plus width. So we say 2 into length plus width. This one will give us the perimeter of 74 that way. So I can now divide by 2 and by 2. Then I group terms now. No, this is now 37. Then I group terms. When I group terms, you discover that this is a 2x squared. Then this is a 30x. Then we are having 5 here. So we can group terms and have 2x squared plus 30x minus 32 equals to 0. Minus 32 that way equals to 0 that way. And looking at this equation, okay, we have already expressed, by the way, and we don't even have to simplify a lot. Even at this point, it had already been expressed. Okay, so you see the equation can still be simplified further. And when you simplify further, you should be talking about x squared plus 15x when you divide through by 2 equals to 0. Yeah, equals to 0. So we can solve this one now because we are told again here in part B to find the actual measurement of the length and width. Actual measurement of length and width. So we solve quadratically by letting the product to be a times c, negative 16, and sum being b, which is 15. So this is negative 16. No. Positive 16 and negative 1. Product negative 16, sum 15. So this is x squared plus 16x minus x equals to 0 minus 16 equals to 0. So from the first two, we factorize x to remain with x plus 16. And then in the last two, we also factorize a negative 1. So that will remain with x plus 16, giving us a 0. So x from the brackets, x plus 16. Outside the brackets, x minus 1. This is equal to 0. That's equal to 0. So the possible values of x shall be, let me use the spaces. The spaces here. Yeah. X plus 16 equals to 0, meaning that x can be negative 16. And again, x minus 1 equals to 0, meaning that x can be positive 1. So those are the possible values of x. Possible values of x. Remember, x is not a distance anywhere. X is not a distance. X is just part of the expression for these distances. So for us to get length, we need x squared, which can be negative 16 squared, then plus 15 into x, 15 into negative 16, then plus 5. So what will be this length? Negative 16 I square, plus 15 into negative 16, then I add 5. I'm getting 21 meters. Again, the length can also be given by the other value of x can be 1. So 1 squared plus 15 into 1 plus 5. And in either cases, I'm getting 21 minutes. 21 meters, sorry. So x can be used as either negative 16 or positive 1, and they will give us the same length. What about the width? The expression for width is x squared, negative 16 plus 15 into negative 16, that way. So the value of the width is going to be negative 16 we square plus 15 into negative 16. This one is giving us exactly 16 meters. And I've said this can also be expressed as width equals to, we use negative 1 squared plus 15 into negative 1. And this is going to give us, a 1 is positive, sorry, 1 is positive. 1 is positive. So this is a 1 squared and 15 into 1, which is also going to give us 16 meters. So in other words, this rectangular floor is measuring 21 by 16 meters. So now we can find part C, the area of the rectangle. 21 by 16. This is what will give us the area, 336 square meters. Length times width gives us area. This is the final question, and we are done with the paper. Thank you so much. Subscribe and share. Remember to support our program using the till number attached, 497772. Thank you so much.